Good evening, everyone. Thank you for joining me tonight, especially those of you who are having trouble sleeping. Is it completely dark outside your window? Or can you see the gentle glow of city lights in the distance? Tonight, I'd like to share some fascinating and amusing stories about light. Please make yourself comfortable, whether you're tucked in bed or relaxing on your sofa, and just listen at your own pace. First, let me ask you something. Do you know how fast light travels? That's right, about 300,000 kilometers per second. In just 1 second, light can circle the Earth 7.5 times. But when we think about the scale of the universe, even light takes an incredibly long time to travel. For example, when you look up at the stars in the night sky, the light you're seeing actually left those stars years, decades, or sometimes even thousands of years ago. In other words, we're constantly looking into the past. Isn't that rather romantic? Take the North Star, for instance. It's about 430 light-years away, so the light we see tonight actually left that star 430 years ago, before the Edo period even began in Japan. People back then might have looked up at the same star, but the light they were seeing was from even 430 years before their time. Here's another interesting story about the speed of light. If the sun suddenly disappeared, we on Earth wouldn't notice for about 8 minutes. That's how long it takes light to travel from the sun to Earth. So for 8 minutes, we'd have this strange situation where the sun no longer exists, but it would still be bright outside. But don't worry. The sun isn't going to suddenly disappear. It should be fine for another 5 billion years or so. It's probably more practical to worry about tomorrow's breakfast than what might happen in 5 billion years. Speaking of light, fireflies are quite mysterious, aren't they? How do these tiny insects create light? Actually, firefly light is incredibly efficient because it produces almost no heat. The light bulbs we use produce a lot of heat along with light, but firefly light is almost 100% light energy. This is called cold light, which sounds quite refreshing, doesn't it? Scientists are studying how fireflies create light to develop more efficient lighting. It's amazing that we can learn so much from such small creatures. Nature really is incredible. By the way, have you ever heard of Cherenkov radiation? This is a blue light that appears when particles move faster than light in water. Wait, is there anything that can move faster than light? You might wonder. Well, the speed of light we usually talk about is in a vacuum. In water, light actually slows down a bit. So under special conditions, particles can move faster than light travels through water. You might have seen the mystical blue glow from spent fuel pools at nuclear power plants. That's Cherenkov radiation. It looks like something from a science fiction movie, doesn't it? But it's a real phenomenon. When I talk about light, I also think about rainbows. Rainbows appear when sunlight bends and separates as it passes through water droplets. But here's something interesting. Each person actually sees the rainbow in a slightly different location. So when you and someone next to you both look up and say, "Oh, a rainbow," you're actually seeing subtly different rainbows. It's a bit philosophical, isn't it? We think we're seeing the same thing, but each person is actually seeing something unique. It's like life itself. And there's something called a double rainbow. Sometimes you can see a fainter rainbow outside the main one, with the colors in reverse order. This is called a secondary rainbow. Finding one makes you feel a bit lucky, doesn't it? Speaking of the colors of light, have you ever wondered why sunsets are red? This has to do with the distance sunlight travels through our atmosphere. During the day, when the sun is directly overhead, light travels a shorter distance through the atmosphere. But in the evening, when the sun is low on the horizon, light has to travel much farther through the atmosphere. Blue light scatters easily along the way. So after traveling a long distance, most of the blue light is gone, and only red light reaches our eyes. That's why sunsets appear red. The same principle explains why the sky is blue. During the day, blue light scatters in all directions, painting the entire sky blue. If Earth had no atmosphere, the sky would be black even during the day, with only the sun blazing brightly. You can see this in photographs from the moon. Let me tell you another mysterious thing about light. Light has this mind-boggling property of being both a wave and a particle. This is called wave-particle duality. Simply put, depending on how you observe light, it can appear to behave like a wave or like particles. It's like an optical illusion that shows different pictures depending on the angle you view it from. This discovery revolutionized 20th century physics. Einstein actually won the Nobel Prize for his research on the particle nature of light, not for his theory of relativity. Surprising, isn't it? Let's talk about the deep sea. Even in the deepest parts of the ocean where sunlight never reaches, there's still light. Many deep-sea creatures can create their own light. This is called bioluminescence. Anglerfish, for example, dangle a glowing lure from their heads to attract prey. In the pitch-black depths, if you saw a lone light, you'd probably be drawn to it. But it's actually a trap. Nature can be quite harsh. Many other deep-sea creatures use light to intimidate enemies or communicate with each other. In that dark world, light serves as a language. Let's talk about artificial light too. The fluorescent lights and LEDs in your room are actually flickering at a speed invisible to our eyes. But they flicker so fast that they appear to be continuously lit to us. Sometimes when you take a photo of fluorescent lights with your smartphone, you can see striped patterns. That's because the camera is capturing the flickering that our eyes can't detect. Human vision is surprisingly imprecise. Talking about light reminds me of lasers. Laser is actually an acronym for light amplification by stimulated emission of radiation. It sounds complicated, doesn't it? But simply put, a laser is light that's been organized to travel in one direction and amplified. Regular light spreads out in all directions, but laser light travels in a straight line. That's why it can read CDs and DVDs or perform precise cutting. Some of you might have played with cats using laser pointers. Cats seem to love chasing that little red dot. They chase it so earnestly even though they can never catch it. It's quite endearing. Let's talk about auroras too. Those mystical curtains of light are actually created when particles from the sun collide with Earth's atmosphere. Green, red, sometimes purple auroras dancing across the sky. I'd love to see them someday. People in regions where auroras are visible have many legends about them. Some say they're the souls of people who have ascended to heaven, or the footprints of gods. Even knowing the scientific explanation, I can understand wanting to believe in such legends when witnessing such beauty. Thinking about light also brings photography to mind. Photography literally means writing with light. A camera is a device that records light coming through a lens. Old photographs required long exposure times, so people had to stay very still. That's why people in old photos always look so serious. It would be difficult to maintain a cheerful smile for several minutes. Digital cameras now allow us to take photos instantly. But the basic principle is the same: recording light. Every photo you take with your smartphone is capturing a moment of light. When you think about it that way, it feels rather special, doesn't it? Let me mention fiber optics too. Much of the information on the internet travels as light through thin glass fibers called optical fibers. Emails, videos, even this program might be reaching you as light. Inside optical fibers, light travels using a phenomenon called total internal reflection, with almost no loss of signal. It's like a bullet train for light. Finally, let me share something a bit philosophical. Our ability to see depends entirely on the existence of light. In complete darkness, we can't see anything. But even with light, if we don't have eyes to receive it, we still can't see. Light, eyes, and brain. Only when these three work together can we see the world. It seems so natural, but it's actually quite remarkable. Tonight, I've shared various stories about light. Light is all around us, yet it's full of mysteries. Tomorrow, when you see the sunrise, or a sunset, or when you turn on the lights in your room, I hope you'll remember some of tonight's stories. Are your eyelids getting heavy? Take a slow, deep breath and relax. I hope you enjoyed tonight's stories about light. Please join me again next time for another sleepless night. Until then, good night everyone. Sweet dreams.